Now let's take all the rules of implication, all 8 of them that we have learned, and combine the rules of all 10 rules of replacement, and use all of those rules to thereby make these derivations of the conclusion in these examples. Okay, so we're bringing all of these rules together in order to derive the conclusion that we need. And the book gives you, the selection from the book that I gave you will give you all these strategies to use in order to figure out how to derive your conclusion if you don't really know where to start. But as always, let's first look at what we're trying to get. We're trying to get our B here. Okay, so if you're looking through the premises here, you can see that there's a B on line 2 here within this conjunction here. And so if you could get this conjunction all by itself, you could use the rule of simplification to bring out this letter B, right? So, but in order to do that, you will need an X to do modus ponens, and therefore get rid of the X horseshoe part to isolate the conjunction here in the antecedent. So again, a lot of this, as you go on, it involves a lot of thinking backwards, really. So you got to get that X by itself, but how are you going to get an X? Well, you know you have X's up here on line 1, but what can you do with that? You can't simplify out anything when the main connective operator is a wedge. You only can do that when it is a conjunction. Because if this was a conjunction, you could isolate out like one side of this, either this side or this side, and then simplify out an X from one of these. But you don't have that luxury because this main operator here is a wedge. So what do you have at your disposal? Well, you actually do have a rule. If you kind of look through your rules here, you have a rule that holds this kind of format. Specifically the rule of distribution. Remember, with distribution, it always involves these conjunctions and disjunctions. It either involves the disjunct of 2 conjuncts or the conjunct of 2 disjuncts here. So, hypothetically, you could do, using this rule, you could change this main operator from a wedge to a conjunction, and therefore get the X by itself, right, using the rule of distribution. But in order to do that, first, again, a lot of this involves a lot of thinking backwards, you will need to get the X's on the same side in each individual conjunct on line 1. So in order to do that, we have to use another rule of replacement. Okay, so that rule of replacement would be commutativity, right? This is where, again, as I was saying, it seems like a formality, but in this case, it is necessary for you to have that the X here on the same side of this of each of these conjuncts. So let's go ahead and use commutativity. And again, with rules of replacement, you can use it on part of it. So the only part that you need to use that rule on is this part right here, the disjunct to the right of the wedge, in order to get it to work. So it will look something like the following. You go X and Y, or, now we switch it, X and A, because X and A and X are equivalent statements, and so we therefore used on line 1 the rule of commutativity. Okay. Now we have it in the right order of letters for us to do the next step, which will be, as we were saying earlier, for line 3, we're going to use the rule of distribution. And once again, rules of replacement work, they're two-way streets, they work back and forth. So if this is the original form that you have it in, you can therefore change it to the following. So you change with distribution, you change the main operator, for in this case it goes from a wedge to an ampersand, and then you pull out the letter that is the same in each, in this case, conjunct. So X here, and then you disjoin the two the conjuncts to the right of each ampersand. So you go Y or A. Right? So now we have it. Took a few bits of twisting and turning, but we have our conjunction here. So now, when we've used line 1, line 3, and now for step 5, we can derive out of line 4, using the rule of simplification, we can derive X. Okay. So there we have it. So now, again, for line 6, using line 2 and line 5, and using the rule of modus ponens, x's cancel out along with the horseshoe, and we're left with the consequent, which is just Q, and B. Right? And we have one more step, again, that formality here that we have to do, because yes, we could use simplification to get the B out, but in order to simplify, the B needs to be to the left of the ampersand. So using line 6 and using the rule of commutativity, we switch this around to B and Q. And then finally, we derive out our B from line 7 using the rule of simplification. And there you have it, the conclusion of this argument. Okay. So, again, some of this stuff, rules of replacement kind of make things a little bit trickier, but always keep in mind, definitely look at the strategies that the book outlines, but always keep in mind what you're trying to get. In this case, you're trying to get this B, and you're trying to figure out what can I do to isolate this B from the Q and the ampersand and the X and the horseshoe. And the rules of replacement allow you to do this.